questions from number 9 through number 16. Yeah, 16, not 10. Yeah. All right, so let's start. Question number 9. Which of the following architecture does the instruction this, given this one, belong to? Belong to A, B. So you can see this one, the operand value comes from register, right? So this one, operand value comes from memory. All right, so then you know which one you should choose easily. Yeah. Number 10, is it possible that in the MIPS architecture, there exists an instruction such that one of its operand can be used both as a source operand and a result operand? So here, looking at the MIPS architecture, do we have that case? For other, for the all possible architectures, we have that case. So we saw some examples. We have that case. But for this question, you have to consider inside the MIPS architecture. Okay? Yeah. MIPS architecture. Remember that small number of addressing modes. Yeah. From there, you can get the answer. Yeah. All right. The next one. In the MIPS architecture, if an instruction is of R-type, then it must have 3 operands. R-type, yeah? So we only have one case in R-type, right? So you look at that. Here, what I'm saying, 3 operands, total operands, right? 3 total operands. Yeah, let me write, the number of operands. When you look at that, source operands and result operands, you need to count both. Source. Now, the values come from, source. You use, input, right? Source, input. Result, output. Output, why we still would call the result output also operand? Because when we look at the instruction, so we have an instruction code, instruction operator. Yeah, so this part is operator. Then this operator is applied on operands, okay? On operands. No matter source or result, all operands, okay? Operator is applied on operands. Yeah, so that's the terminology we use here. Yeah, so no matter source or result, we count as operands under this operator. Okay, all right. Yeah. Next one, number 12. The displacement mode is a special case of the register direct mode. Yeah. Look at this statement carefully. Yeah. Which one is a special case of which one? Okay. Yeah. So you need to get a displacement mode example first, then register indirect example second, you compare, right? Yeah. Yeah. All right. Number 13, in the MIPS architecture, a store instruction has a destination in the main memory. Here, when I say destination, I do not include destination field. Okay? Yeah. In my lecture, I separate those 2 different meanings. Destination field, when we say that, you can find a certain number of bits in the instruction that are used for destination. That's the destination field. Destination you cannot find. You may not be able to find certain number of bits inside one instruction to give you the destination, but you can generate destination indirectly. So here we're looking at the case. You have some special way to generate the destination indirectly. If you have that, then you have a destination, right? You have a destination. All right, number 14. In the MIPS architecture, if an instruction has the destination field, so this time you have a destination field inside your instruction, then it must be an R-type instruction. True or false? Okay, yeah. True, so you need to explain why it is true, right? If it's false, yeah, so usually if you want to say this statement is false, can you find a counter example? Counter example, right? Yeah, because one counter example is enough to make this whole statement false. Yeah, you need to find some special case, special instruction way you can use to say it is false. Okay, all right, so that's number 14. Number 15, in the MIPS architecture, when the RT field of an instruction is used as the destination field, the instruction must be an I-type ALU instruction. This statement, true or false? Yeah. Here we are talking about, here, RT field, right? Yeah. RT field of an instruction is used as destination field. Yeah. You need to look at all the possible cases. All the possible cases. Yeah. If you can get a conclusion, must be I-type ALU instruction. Okay? Yeah. If you want to say it is false, the same logic. Can you find a counter example? Right? Can you find a counter example? If you can, then it's false. Yeah. So that means you can find instruction not a I-type ALU, but RT field is used as destination field. Okay? Yeah. So you can answer this question. Yeah. The last one of video number 2, in the MIPS architecture, if an instruction can access the memory, read or write. Yeah. Only read, write, load, store instructions can access memory. Then it must have a destination. Okay. Here I do not say destination field, right? So here I do not say destination field. I just say destination. So you do not consider the, if there is no destination field, you can still consider if there is a destination. All right, yeah. Okay, all right. So you can see in this part we have several questions related to destination and the destination field. So you need to, really understand the difference. All right, so I complete part 2 right here.